Alright, let's start then. So the first question is, the product of two irrational numbers is an irrational number, maybe rational, irrational, none of this. Okay, so let's take two irrational numbers, for example. So let's take root 3. Let's take root 3 again. So let's say their product. So then this is equal to 3, right? Well, actually wrong, because it does not say like these numbers need to be equal, so you cannot just assume that. Let's assume different numbers. So yeah, let's say one is root 3 and the other one is root 9, for example. So if you multiply them, you get square root of 27, right? You might be tempted to say, oh well, it gives you an irrational number. But again, that's also not true. Clearly it can be either this or this, right? So the answer is C. Product of two irrational numbers may be rational or irrational, because this can also be true and this case can also be true, since they have not specified which one. So you need to assume that both of them might be true. So that's option C. Alright, so let's move on to question number 2. What does question number 2 say? So question number 2 says, which term of the AP 3, 8, 13, 18 is 78? So that means we need to find some AN, and we need to find the n here. So that's our answer. If you recall, the formula for AN is just A1 plus n minus 1 times D. Now what are these terms? So this is the first term, right, which in our case is 3. N we need to find out. D is just a common difference, so that would be this term minus this term, right? So, and AN is obviously 78, which is given to us. So substituting all this, 78 is equal to 3 plus n minus 1 times what's the common difference? The common difference is just 8 minus 3. You could choose any two. So 18 minus 13 would also give you the same result, or 13 minus 8. It doesn't really matter. So now we have 78 is equal to 3 plus n minus 1 times 5. If we simplify this, 78 minus 3 is equal to n minus 1 times 5. So we have 75 is equal to n minus 1 times 5. Now we divide both sides of this equation by 5. So we get 75 divided by 5 is equal to n minus 1 times 5. This thing divided by 5, right? So if we simplify this, we get 75 divided by 5 is 15 is equal to n minus 1, or n minus 1 is equal to 15. We're just representing it in another way, or n is equal to 15 plus 1, or n is equal to 16. And the question was, which term of the AP? So n is equal to 16. This is option C. Moving on to question number 3. So it says, if 1, 0 of the polynomial f of x is equal to 5x squared plus 13x plus k is the reciprocal of the other, then the value of k is. So first thing to notice is this is a quadratic polynomial. So the product of the two zeros, zeros just means that when you set f of x is equal to 0, you'll get some value of x, or let's say x1 and x2. Those are the two zeros of the quadratic polynomial, right? So for any equation of this form, it can be written as sort of ax squared plus bx plus c, right? So that's a quadratic polynomial. If you set this equal to 0, so you'll get some value of x, okay? Like I said, x1 and x2. For any polynomial that has this form, the product of the zeros is nothing but c by a, okay? So if you divide this equation throughout by a, so let's say a in this case is just the coefficient of x squared. So if you divide f of x by 5, so what do we get? We get 5x squared divided by 5 plus 13x divided by 5 plus k by 5, right? So if you set this equal to 0, well, since the zeros are in reciprocal, so this term should be equal to the product of the zeros, right? So now if one zero is x1, the other obviously has to be 1 by x1, and x1 cannot be 0. That's the condition. So if we multiply this, then this should be equal to k by 5. So what do we get here? K by 5 is equal to 1, or k is equal to 5. This is nothing but option D. Okay. So moving on to question number 4. Moving on to question number 4. So the roots of the quadratic equation x squared minus 2x minus 8 is equal to 0 are. So we just factorize this. So let's say x squared minus 2x minus 4 is equal to 0. So I'm just splitting 8 into 4 plus 4. So now we can rearrange this as x squared minus 4 minus 2x minus 4 is equal to 0. X squared minus 4 is of the form x squared minus 2 squared minus 2x minus 4 is equal to 0. So if you notice, this is of the form a squared minus b squared, which can be expressed as a plus b times a minus b. So we'll do just that, x minus 2 times x plus 2 minus 2. So if we factorize this part, we get x plus 2 is equal to 0, or so this can be again factorized, x plus 2. If we take that common, so we're left with x minus 2 minus 2, which is equal to 0. So now we get x plus 2 times x minus 4 is equal to 0. So x plus 2 can be 0, or x minus 4 is 0. This gives us x is equal to minus 2 and x is equal to 4. All right. We can check if our solution is correct. So just substitute x is equal to minus 2 in this equation. So we get minus 2 squared minus 2 times minus 2 minus 8 is equal to 0. So this gives us 4. Minus 2 times minus 2 is plus 4. Minus 8 is equal to 0. This is indeed true. We can also substitute x is equal to 4 in that equation. So that gives us 4 squared minus 2 times 4 minus 8 is equal to, well, 4 squared is 16 minus 8 is equal to 0. So that's also correct. So that gives us x is if you look at the options, so we need to express it. So minus 2 comma 4, or 4 comma minus 2. So that's just option A. All right. So now we move on to question number 5. So what is question number 5? Question number 5 says, for what value of k, okay, so there's some k that we need to find out. the pair of linear equations, okay, 3x plus 2y is equal to 5 and 6x plus ky is equal to 10, will have infinite number of solutions. Okay, so infinite number of solutions just means that these coefficients, they should be same when you factor it in its simplest form, or like if you want to look at it in the form of a graph. So if you draw a line, let's say that's this line is for this one, let's call it L1 for this equation. Let's call the line L2 for this equation. So the line must be same. So one should be on top of the other. So L1 and L2 must be same if you want to look at it that way. Which simply means that if you observe these equations, right, it looks like if you multiply the first equation by 2 on both sides of the equation, that should do the job. So the condition for infinite number of solutions must be that it's the same line. So obviously these coefficients need to be the same. So 3 and 2 you have in the first equation, next you have 6 and k. So k is nothing but twice of whatever this is. So k is equal to 4, which is just option number A. Okay, because if you observe 3x plus 2y is equal to 5, well, this is in its simplest form, whereas 6x plus 4y is equal to 10. If you divide both sides of the equation by 2, well, you just have again 3x plus 2y is equal to 5, right? So these are identical lines. Therefore, the value of k must be 4. Okay, what do we have in question number 6? So question number 6, the distance between the 2 points P, the coordinates of which are 2, minus 2, and Q minus 1, 1, y is equal to 5 units. So if you're given 2 coordinates, let's say x1, y1, and x2, y2, the distance formula says the distance between these 2 points are x2 minus x1 whole squared plus y2 minus y1 whole squared and the square root of that. Okay, so we just substitute the numbers. So distance is given as 5, which is equal to x2 minus x1 is minus 1 minus 2 whole squared plus y2 is just y minus 2 whole squared of that and the square root. So 5 is equal to minus 1 minus 2 is minus 3 squared plus y minus 1 times minus 2 is plus 2 whole squared, square root of that. So 5 is equal to, well, minus 3 squared is 9 plus y plus 2 whole squared and square root of that. Now we square both sides, so squaring both sides of the equation. What do we get? So 5 squared is equal to 9 plus y plus 2 whole squared, right? If we rearrange this, this gives us 9 plus y plus 2 whole squared is equal to 25, or y plus 2 whole squared is equal to 25 minus 9, or y plus 2 whole squared is equal to 16. At this point, you can go ahead and solve the quadratic equation and get values for y. Or what you can do is, since you're already given the options, you can just check for which of the four options. Y plus 2 whole squared is equal to 16, right? So let's check option A, which says y could be minus 2 or minus 6. So if we check that, so what do we get? Minus 2 plus 2 squared is equal to 0, clearly not equal to 16. So option A is not the answer. Let's check option B, which says 2 comma minus 6. So 2 plus 2 whole squared, so that's 4 squared is equal to 16. Okay, that satisfies this. What about minus 6? Minus 6 plus 2 whole squared is equal to, well, minus 4 squared, which is also 16. So, well, we have option B as the answer. You don't have to check option C and D because we already got the answer. Anyways, they're wrong. So option B is the correct answer. The values for y, there are 2 comma minus 6. Okay. All right, moving on. So what do we have in question number 7? So question number 7 says, if sine 2 theta is equal to 1, then tan theta is equal to what? Alright, so let's try to simplify the equation first. So sine 2 theta can be rewritten as sine theta plus theta, right? That's equal to 1. If you recall, sine of A plus B is nothing but sine A cos B plus cos A sine B. In this case, A and B are both the same, theta, so we can rewrite the equation as sine theta cos theta plus cos theta sine theta is equal to 1, which is nothing but 2 times sine theta cos theta is equal to 1. Right? So now we want to convert it somehow into tan theta, for example. Or that's what we're asked for. So how might we convert this into tan theta? So tan theta, if you recall, is nothing but sine theta by cos theta. So if we divide both sides of this equation by cos squared theta, then we would get 2 times sine theta by cos theta is equal to sec squared theta, right? And then sine theta by cos theta is nothing but tan theta, so 2 times tan theta is equal to sec squared theta. Now we'll use a handy trigonometric identity which says 1 plus tan squared theta is equal to sec squared theta. So we have 2 tan theta is equal to 1 plus tan squared theta, or rearranging the equation we get tan squared theta minus 2 times tan theta plus 1 is equal to 0. So we just switched this side of the equation to the other side, just rearranging terms, and we collected this. So we get this. This is of the form a squared minus 2 times a times b plus b squared, which is nothing but a minus b whole squared. So if we write it that way, this just becomes tan theta minus 1 whole square is equal to 0, which means tan theta minus 1 is 0, tan theta is equal to 1. That's our answer. So tan theta is equal to 1. That's what we needed to find. So that's option number C. So this is nothing but option C. Next, we move on to question number 8. So question number 8 says, in a circle of radius 21 centimeters. So let's draw a circle first, right? So we have our circle. The radius is 21 centimeters. So let's represent that. So that's 21 centimeters. An arc subtends an angle of 60 degree at the center. So okay, so there's some arc. Let's say the arc is from here to here. That arc subtends an angle of 60 degrees here. Then the area of the sector. So they're asking for this area formed by the arc is how much? So first of all, since we have the radius r equal to 21 centimeters, let's find the area. Okay, so let's find the area. So what is the area? Well, the area is nothing but pi r squared, which is pi times 21, sorry about that, 21 squared, and the unit would be centimeter squared. Okay, we need not simplify it right now. Let's understand this first. So if this angle subtends 60 degrees, and the full angle, if you remember, that's 360 degrees, right? So 60 degree is just 1/6 of 360 degree. That means this area would also be 1/6 of the whole circle area, right? So the required area is what is 6? So we have 60 degrees. The total angle is 360 degrees. So that's 1/6 of the total area, which is pi r squared. So now we simplify this, which is 1/6 times, assuming pi is 22/7. So we get 21 times 21 centimeters squared. Let's simplify this. So 7 times 3. 3 times 2 is 6, and 2 times 11. So 11 times 21, which is 231 centimeter squared. So that's our answer, which is option C, I believe. Next, so question number 9. What does question number 9 say? So in triangle ABC, so there is a triangle. Let's try to draw it roughly. In triangle ABC, right, DE is parallel to AB, so there is a line segment DE which is parallel to so DE is parallel to the side AB. If CD is equal to 3 centimeters, so let's represent that here. So that's 3 centimeters. EC is equal to 4 centimeters. Okay, and BE is equal to 6 centimeters. Then DA is equal to what? So this. There is a neat property of triangles which says in this diagram, so that would be CD divided by DA is equal to CE divided by EB. Well, all the variables are given, so we can easily find this DA. Let me just state the property here. So if a line is drawn, so in this case we drew DE parallel to one side, so parallel to the side AB, one side of a triangle to intersect the other two sides So it's intersecting the other two sides at two distinct points. In our case, the points are D and E. Two distinct points. Then the result says, then the other two sides are divided in the same ratio. So that's what's happening here. CD divided by DA is equal to CE divided by EB. So now we just got to simplify this. Let's just substitute the values. So CD is 3 divided by DA is what we have to find. CE is 4 and EB is 6. So we simplify this. DA is equal to cross multiplying this. So 3 times 6 divided by 4, which is nothing but 18 divided by 4, which is 9 divided by 2. That is equal to 4.5 centimeters. So that's again option C. Right. Moving on. So question number 10, it's a probability problem. So the question says, in tossing 3 coins, the probability of appearance of at least 2 heads is. Okay, so 3 coins are tossed. Cool. So what are the possible outcomes in tossing? First of all, how many outcomes do you think would be there? So just pause the video and try to figure out. So let's say there are 3 coins, C1, C2, C3. Well, coin 1 can really be heads or tails. So there are 2 possibilities here. Similarly, coin 2 also has 2 possibilities and coin 3 also has 2 possibilities. So in all, there would be 8 possible outcomes. Well, what are those outcomes? First possibility is pretty straightforward. So all the coins can give you heads, which means head, head, head. That's one possibility. Or you can get tail, tail, tail. Another possibility is head, head, tail, or head, tail, tail. So those are 4 possibilities. What are the other possibilities? Well, head, tail, head, tail, head, tail. Then we have tail, head, head, and then tail, tail, head. Now, these are the possibilities that you can get when 3 coins are tossed. How did I figure this out? Well, you just have to write them down, sort of, and see. The question says the appearance, the probability of appearance of at least 2 heads. At least 2 heads means there could be 2 heads or more. So this is a valid possibility. This is also a valid possibility. Well, this is not, and this is also, this is not, this is not, this is not. So how many outcomes are there? So the probable outcomes, there are 4 that we need out of the total 8. So the probability is just 1 by 2, which is option number D. All right. We move on to question number 11. So that's the second section. Question number 11. What does this say? So question number 11 says, find the HCF of 96 and 404 by prime factorization method. So, well, okay, let's prime factorize 96. So 2 times 48 is 96. 2 times 24 is 48. 2 times 12 is 24, 2 times 6 is 12, and then 2 times 3 is 6. So 96 can be written as 2 times 2 times 2 times 2 times 2 times 3. Alright, let's prime factorize 404. So 404, 2, that's 202. Again, if you divide it by 2, 101. 101 happens to be a prime number, so 404 is really equal to 2 times 2 times 101. Now, HCF of 96 and 404 is nothing but whatever the common factors are here. So 2 is common. Alright, another 2 is common, another 2 is common. That's really pretty much it. So we have 2 times 2, which is 4. Therefore, the HCF is 4. Alright, that's fairly straightforward. Let's move on to question number 12. Interesting question. So find the sum of the first 10 terms of the arithmetic progression 2, 5, 8, and so on. So the AP is 2, 5, 8, and so on. We need to find the sum of the first 10 terms, which is in other terms S10. If you recall, the formula for sum of the first n terms of an arithmetic progression Sn is equal to n divided by 2 multiplied by 2 times a1 plus n minus 1 times the common difference. So S10 really is equal to 10 divided by 2 multiplied by 2 times what is a1. A1 in this case is nothing but 2, so the first term of the progression, 2 times 2 plus n minus 1 is 10 minus 1 times d. What is the common difference? Well, d is equal to this term minus this term, or you could also do it this term minus this term. It really doesn't matter. So let's do 8 minus 5, which is 3. So common difference is 3. Now S10 is nothing but 5 multiplied by 4 plus 9 times 3, which is equal to 5 times 4 plus 27, which is equal to 5 times 31. That's equal to 155. That's it. That's our answer. Now we move on to question number 13. So question number 13 is from coordinate geometry. It says find the distance between points P minus 5 comma 7 and Q minus 1 comma 3. If you represent the points as x1 comma y1 and x2 comma y2, then the distance formula says that is the distance between 2 points in coordinate geometry, that's nothing but x2 minus x1 whole squared plus y2 minus y1 whole squared and square root of that. So in our case, we substitute the values. So x2 minus x1 is minus 1 minus minus 5, that whole squared, plus y2 minus y1 is 3 minus 7 whole squared and square root of that, which is really equal to minus 1 minus minus 5. So that's minus 1 plus 5 whole squared plus 3 minus 7 is minus 4 whole squared and square root of that. Oh, sorry, that was really bad. Yeah, so that's equal to 4 squared plus minus 4 squared and under root, which is equal to 16 plus 16 and square root of that. So square root of 32, which is equal to 4 times root 2. how did I get 4 root 2? Well, 32 could be factorized as 2 times 16 square root, and then this could be written as root 2 times root 16. Well, square root of 16 is just 4, so we get 4 times root 2. And since distance cannot be negative, so we're not considering the possibility where the under root might give you a negative answer. So that's not considered here. So the answer is really 4 root 2. Okay. So we move on to question number 14, which says, question number 14 is also from coordinate geometry. So find the coordinates of the point which divides the join of in the ratio. Okay, so 2 points are joined. Let's say there is some point, we call it P, that's joined to another point Q. The coordinates are -1, 7 and 4, -3. Okay. As usual, we assume that this is x1, y1 and x2, y2. So there's some point in, so since the question does not mention whether the point is on the line or somewhere out here, we're assuming that the point lies here. So let's call it whatever, M. So the question is, this thing divides it in the ratio of 2:3. Okay. So we need to find the coordinate. Let's x, y. We need to find that. So if we denote this part by m and this part by n, the ratio I mean, so m by n is equal to 2/3 really. So this is given to us. We need to find the coordinates, x and y. Okay. So we can use the handy section formula here, which really says, so the coordinates x and y, which we want to find, so that could be represented as m times x2 plus n times x1 divided by m plus n. So we have already represented what these variables mean above. The y coordinate is given by m times y2 plus n times y1 divided by m plus n. So the required point m in our case is nothing but m times x2. So let's just assume this whole thing is equal to some value a. Okay, so m becomes 2, sorry, yeah, I mean we could either do this or we could just substitute in terms of n. I think I'll just substitute it in terms of n. So m just becomes 2n/3. So m becomes 2n/3. What is x2? X2 is 4 plus n, I'll keep it as is because then we can cancel it out later. N times what is x1? X1 is -1 divided by m. What is m again? 2n/3 plus n, comma, well, denominator would be the same, so 2n/3 plus n. What's the numerator? So m times y2, so m is 2n/3 times what's y2? Y2 is -3 plus n times what's y1? Y1 is 7. So we just got to simplify this further. So that gives us 8n/3 minus n divided by 2n/3 plus n, comma, minus 6n/3 plus 7n divided by 2n/3 plus n. Okay, so first of all, let's get rid of all the n's. Well, so we can write this as n times 8 by 3 minus 1 divided by n times 2 by 3 plus 1. Similarly here, n times, so we can simplify this. Minus 6 by 3 is nothing but minus 2 plus 7. And in the denominator we have n 2 by 3 plus 1. Alright, so we cancel the n's here. This is again equal to 8 minus 3 divided by 3 divided by 2 plus 3 by 3, comma 5 divided by 2 plus 3 divided by 3. So that's our final coordinate, which on simplification gives 5 by 3 divided by 5 by 3, comma 5 times 3 by 5. So this 3 goes to the numerator, and I've just done the simplification, so the coordinate becomes 1 comma 3. That's our x comma y. So that's the required coordinate, and well, that's our answer. So this point we figured it out, so that's just 1 comma 3. All right, that's fairly well, I mean, it's complicated in the sense there's a lot of fractions and stuff, but I think once you get a hang of the formula, it's fairly simple. So let's solve question number 15. What does 15 say? So x times tan 45 times sine 30 degrees is equal to cos 30 times tan 30, and I need to find the value of x. Okay, so since these are all standard angles, I can just plug in the values. So x times tan 45 is 1, sine 30 is 1 by 2, cos 30 is root 3 by 2, and tan 30 is 1 by root 3. So we just, okay, this cancels. So x by 2 is equal to 1 by 2. Multiplying 2 on both sides of the equation, we get x by 2 times 2 is equal to 1 by 2 times 2. Therefore x is equal to 1, which is our required answer. Okay, next we have question number 16, where we have the diagram. So let's draw that. So the diameter passes through obviously the center, and then there's a tangent from an external point C. Let's represent that. So that's point C, that's our A, and then these are also connected. Okay, that's center O. This angle is 130 degrees, and this is B. So the question is, okay, so if BOC is 130, then find angle ACO. So I need to find this angle, right? Okay, no problem. That's equal to how much? So a neat property of triangles and circles tells us that a tangent to a circle where it intersects the radius, so that's perpendicular. The tangent must be drawn from an external point. Okay, so that's the result we're going to use. So if you look at this line and this angle, that's 130, and you know, on a straight line, this entire angle, that's 180 degrees. So in this triangle, for example, if you look at this angle, so that is our angle AOC, that's equal to how much? Well, that's nothing but 180 degrees minus 130 degrees, which is equal to 50 degrees. Why? Because of this reason. Okay. Now in triangle AOC, right, using angle sum property, what do we get? Well, angle ACO plus angle AOC plus angle OAC is equal to 180 degrees. That's just the angle sum property of a triangle. Okay. So angle ACO plus what is angle AOC, we figured out is 50 degrees, plus what is angle OAC? OAC is 90 degrees. That's equal to 180 degrees. Why is angle OAC 90 degrees? That's because tangent is perpendicular to the radius at the point of tangency. So we have there that therefore angle ACO is equal to 180 degrees minus 140 degrees, which is equal to 40 degrees. That's our answer, right? Cool. Let's solve question number 17 now. So question number 17 says simplify 1 plus tan squared theta divided by 1 plus cot squared theta. I mean, you can use the identity to simplify this, honestly, but okay, let's just go back to basics and try to solve this. So this can be rewritten as tan squared theta is nothing but sine squared theta by cos squared theta, and cot squared theta is the reciprocal of tan squared theta, so this is cos squared theta by sine squared theta. Okay, cot theta is equal to 1 by tan theta, therefore cot theta is equal to 1 divided by sine theta by cos theta, which gives us cot theta is equal to cos theta divided by sine theta. Okay, I hope that's clear. Now we simplify this further, so that's cos squared theta plus sine squared theta divided by cos squared theta divided by 1 plus, sorry, not 1 plus, that's sine squared theta plus cos squared theta divided by sine squared theta. So we know that cos squared theta plus sine squared theta is equal to 1. Using that result, so this is just 1, this is also 1, so that's just 1, that's also 1. Therefore we get sine squared theta by cos squared theta, which is equal to tan squared theta. So that's our answer. That's the simplest form, right? So we move on to question number 18 now. Question number 18 says find a quadratic polynomial, the sum of whose zeros is 4 and product is -6. Okay, so let's assume the quadratic polynomial and the quadratic equation is of the form ax squared plus bx plus c is equal to 0. That's our quadratic equation. So we know that sum of zeros of a quadratic equation in this form is equal to minus b by a, and the product of zeros is equal to c by a. Okay, then this is given to us. So this is given as 4 and this is given as minus 6. So let's consider this equation and this equation separately. So minus b by a is equal to 4, and the other equation is c by a is equal to minus 6. So b is equal to minus 4a and c is equal to minus 6a. Now to get the equation, we just have to substitute these values back to this equation, so that just becomes ax squared plus what is b, let's just write it down, c is equal to 0. So that just becomes ax squared plus what is b, well b is just minus 4a times x plus what is c, c is minus 6a, that is equal to 0. Let's simplify it further. So ax squared minus 4ax minus 6a is equal to 0. Now we divide the equation, so divide by a. If we divide the equation on both sides by a, so 1 by a times ax squared plus minus 4ax minus 6a is equal to 1 by a times 0. Well, right hand side is just 0. The left hand side becomes x squared minus 4 times x minus 6. Okay, because this a cancels out the a inside the parenthesis. So the equation is of the form x squared minus 4x minus 6 is equal to 0. Therefore, the polynomial f of x is nothing but x squared minus 4x minus 6. That's our answer. We move on to question number 19 now. So what does question number 19 have to say? It says the circumference of the base of a right cylinder is 132 centimeters. Okay, so there's some cylinder. Let me try to draw it. Okay, that doesn't look right, but please bear with me. Okay, so the circumference of the base, okay, so this circumference, that's 132 centimeters. And its height, so this height is 25 centimeters. Find its radius, so I need to find the radius. Let's call it small r. We don't actually need to use the height in this case. That's just confusing information. Since the circumference is given, so what's the formula for the circumference? Well, circumference is nothing but 2 times pi times r, which is 2 times 22 by 7 times, what is r? We don't know, but we know the circumference, that's equal to 132. So we can easily find r from here. So r is nothing but 132 times 7 divided by 2 times 22, which is, on simplification, we'll get r is equal to 21 centimeters. Okay, how can we simplify this? Well, let's start slowly. So we try to divide 132 by 2, that's nothing but 66, and well, 66 divided by 22 is just 3, and 3 times 7 is 21. So that's our answer. Let's move on to question number 20 now. So question number 20, let me draw the figure first. Okay, so there's the center of the circle, there's the point P, then there's the point Q, that's the center of the circle, there's a point T outside the circle that's represented like this. We connect this. All right, so this angle is given as 125 degrees. In figure, if TP and TQ are two tangents, okay, so using the result given before, this would be 90 degrees, this would also be 90 degrees. Why? Because a tangent drawn from an external point to a circle is perpendicular to the radius at the point of tangency. Okay, so I need to find angle PTQ. So this is the angle that I need to find. All right, since I know the other three angles, I can use the angle sum property of a quadrilateral, which is nothing but 360 degrees. So 125 degrees plus 90 degrees plus, let's call this angle PTQ plus 90 degrees. So that should be is equal to 360 degrees, right? Because it's a quadrilateral, so the angle sum would be 360. Therefore, angle PTQ is equal to 360 degrees minus, well, 180 degrees minus 125 degrees, which is equal to 55 degrees. That's our angle PTQ. So that's the answer, right? So moving on to question number 21 now. What does question number 21 say? Question number 21 is in section 3. Okay, so if alpha and beta are two zeros of the quadratic polynomial, okay, so f of x is equal to x squared minus 7x minus 4, then find the value of alpha squared plus beta squared. First of all, let's set f of x is equal to 0. So now this becomes a quadratic equation. So x squared minus 7x minus 4 is equal to 0. Okay, we need to find alpha squared plus beta squared. Let's try to simplify that. So what is alpha squared plus beta squared is equal to? Can I write it as alpha plus beta whole squared minus 2 times alpha times beta? Of course I can. Why did I write it this way? Well, because given this quadratic equation, we can find its sum of roots, because alpha and beta are the two zeros. So this is nothing but sum of roots, and alpha times beta is nothing but product of roots. So what is the sum of roots? Sum of roots is nothing but minus b by a. In this case, sum of roots is minus 7. A is just 1, so we need to write it. That squared minus 2 times what's product of roots? Product of roots is c by a. C in this case is minus 4, so minus 4. You need to be careful with the signs. So if the standard quadratic equation is in this form, the sum of roots is what? Minus b by a, that's sum of roots, and the product of roots is c by a. So that's what we're using here. minus 7 squared is 49, minus 2 times minus 4 is plus 8, so that is 57, which is alpha squared plus beta squared. So that is our answer. You could of course attempt to solve this quadratic equation and then try to find the sum of the square of the roots, but that's going to take a lot more time. This is a much simpler approach. Okay, so moving on to question number 22 now. What does 22 say? So question number 22 says, if cot theta is equal to 7 by 8, then find the value of 1 plus sine theta times 1 minus sine theta divided by 1 plus cos theta times 1 minus cos theta. Well, the naive approach would be to draw a triangle, right? Draw a triangle and then try to find sine theta, cos theta, and then substitute. But that would take a lot of time and it's unnecessary, because let me show you how to do it simpler. So this is a plus b times a minus b. So you can just write a squared minus b squared, right? Similarly, for the denominator, you could write a squared minus b squared. Now we have 1 minus sine squared theta divided by 1 minus cos squared theta. Again, if you remember, 1 can be written as sine squared theta plus cos squared theta. So we'll write it as sine squared theta plus cos squared theta. That's just 1 minus sine squared theta. Similarly, for the denominator, we'll write it as sine squared theta plus cos squared theta minus cos squared theta. Now, sine squared theta and sine squared theta minus sine squared theta is 0. Cos squared theta minus cos squared theta is also 0. So we're left with cos squared theta by sine squared theta, which is equal to cot squared theta. And what is this equal to? Well, cot theta was given as 7 by 8, so this is just equal to 7 by 8 whole squared, which gives us 49 by 64. That's our answer. Let's solve question number 23 now. So question number 23, the length of the minute hand of a clock is 14 centimeters. Okay, so that's just the radius of the circle, assuming the clock is circular, which obviously it is 14 centimeters. Find the area swept by the minute hand in 5 minutes. Okay, think for a second. So what is the minute hand? So it goes around the circle once completely in 1 hour, right? So if you draw a circle, okay, the radius is 14 centimeters. This minute hand goes around this whole circle in 60 minutes. The question is, how much area did it sweep in 5 minutes? So if the minute hand sweeps pi r squared area in 60 minutes, how much area will it sweep in 1 minute? Well, in 1 minute it will sweep pi r squared divided by 60, right? That's for 1 minute. So then how much area will it sweep in 5 minutes? Well, it's just simple unitary method. So 5 times whatever this area for 1 minute. So that's nothing but pi r squared by 60. So now that's the required area, which is equal to 5 times, what is pi r squared? Well, pi, let's assume, is 22 by 7 times what is r squared in this case, it's 14 times 14, and I have 1 by 60 here. So simplifying this, 7 times 2 is 14. Well, again, what else can I simplify? Let's try to do this. So 2 times 30 is 60, right? And then 5 times 6 is 30. I can further divide by 2. So 2 times 3 and 2 times 7. So that gives me 154 by 3 centimeters squared. Okay, I hope you understood. So it's fairly simple. In 60 minutes it will sweep the entire area of the circle, which is pi r squared. So in 1 minute it will sweep 1 by 60 of that. In 5 minutes it will sweep 5 times 1 by 60 of the whole area. Similarly, let's say in 10 minutes it would sweep 10 times the entire area divided by 60, because this is per minute. So in 10 minutes it will cover this area. Okay, so you can leave it like that. If you want to further divide it, you can divide it. It's probably close to something like 51 point something centimeters squared. Okay, next we move on to question number 24. So question number 24 says the radii of two right circular cones are in the ratio 2:3. Okay, so there are two cones. Let's say one is like that, and then there's one more, not identical, I mean the dimensions are different. So there are two cones, their radii. Okay, so let's say r1 divided by r2 is equal to 2 by 3. Okay, and then their heights. Okay, so h1 and h2 heights are in the ratio 3 by 2. Find the ratio of their volumes. Okay, so I need to find v1 by v2. Well, what is v1? Well, v1 is nothing but the volume of the first one. Let's call this as 1 and this is 2. So what's the volume, formula for volume of a right circular cone? So that's 1 by 3 pi r square h. Since this is for the first one, so this is r1 h1. Similarly, for the second right circular cone, it will be 1 by 3 pi r2 squared h2. So now we just need to find this out. Well, this is just constant, so this cancels. So really we're just left with r1 by r2 whole squared times h1 divided by h2, which is equal to 2 by 3 whole squared times 3 by 2. That is nothing but 2 by 3 times 2 by 3 times 3 by 2. So we can cancel this, and that leaves us with 2 by 3. So v1 by v2 is equal to 2 by 3. That's it. Okay, so solving the last question of this section. So question number 25 says find the mean from the following table. Okay, so you're given a group distribution table, also the frequency and so on. So let's make a table. We call this class. Then we have the frequency, which is also represented by fi. Then the class mark, and finally we have, this is represented by xi, and finally we have the multiplication, so fi xi. This is really all we need to calculate the mean. So let's just write them down one by one. So class 0 to 10, 10 to 20. So this is a balanced class. The end point of this and the starting point of this are the same, so we need not do the hard work of balancing this. 20 to 30, 30 to 40, and then 40 to 50. What are their frequencies? 10, 22, 40, 16, and 12. Class mark is nothing but this plus this divided by 2. So 0 plus 10 divided by 2, which is nothing but 5. Similarly, 20 plus 10 divided by 2 is nothing but 15. 25, 35, and so on. Right? That's our xi. Fi xi means this multiplied by this. So we get 50, 330, 1000, then 560, and 540. Okay. So what is the mean? Mean is represented by x bar often. That is nothing but sigma xi fi divided by sigma fi. Well, don't get scared of this notation. This just means sigma xi fi just means sum all of these values. Okay. Similarly, sigma fi just means summation of these values. If there was something such as sigma x of I, then you would have just added this up. Okay, but this is not in the formula, only this part is. So what is the sum of this whole thing? That is 2480. What about summation of this? So that's 100. Therefore we plug in the values. So 2480 divided by 100, which is equal to 24.8. That's our mean. That's what we have to calculate. That's all. Fairly simple, isn't it? Next we have question number 26 and a new section. So section 4, question 26, it says solve. Okay, we'll solve it. 4 divided by x plus 3y is equal to 14. 3 divided by x plus, or not plus, minus 4y is equal to 23. Cool. See, reciprocals are quite hard to deal with. So if you just go ahead and try to solve this, you will get an xy term, which is not ideal to handle. So I'll make a cheeky substitution. Let 1 by x be denoted as v. Why v? I just like the letter. So if we substitute v in place of 1 by x, the new equations that we need to solve are 4 times v. V is nothing but 1 by x, so this one I have substituted, plus 3y is equal to 14, and then 3v minus 4y is equal to 23. Now I have two equations. This is linear equation, a pair of linear equation in two variables. So how do we solve this? Let's multiply 3 to this equation and 4 to this equation. So we have 12v plus 9y is equal to 42, and we have 12v minus 16y is equal to 92. Okay, so we just use simple elimination now. So subtract this becomes plus, that's 2 minus. So eliminating the variable v, we get 9y plus 16y. Okay, wait, let me just not jump steps. 9y minus 16y is equal to 42 minus 92. Okay, so we're subtracting this equation from the first equation. So this gives us 9y plus 16y is equal to minus 50, or 25y is equal to minus 50, or y is equal to minus 2. Now we substitute the value of y in the first equation. This is this equation, okay? So 4v plus 3y is equal to 14. Substituting y is equal to minus 2, we get 4v plus 3 times minus 2 is equal to 14, which gives us 4v minus 6 is equal to 14, or 4v is equal to 14 plus 6 is equal to 20. So 4v is equal to 20, or v is equal to 20 is equal to by 4, so that's equal to 5. Okay, so v is equal to 5. But that's not the answer. So we assumed as 1 by x. We need to find x and y. This is one of the answers. So 1 by x is equal to 5. Therefore x is equal to 1 by 5. So x is that, and y is equal to minus 2. That's our required answers. And we're done with question 26. So now we move on to question number 27. What does question 27 say? So question 27 says, in what ratio does the point P is minus 4, 6, divides the line segment joining points A minus 6, 10 and B 3, minus 8. So we need to find in what ratio. So just to represent it for ease of visualization, so if this point is A and this is B, there's some point P which divides it in some ratio, let's say n, m is to n. Okay, so we need to find the value of m and n. Or actually no, we need not find it separately, we have to find m is to n, like m divided by n. If you find this value, then we're done. Okay, so let's represent as usual as x1 y1 and x2 y2, and this we're representing as, let's say, x comma y. Okay, so if we use the section formula x comma y, okay, so that's really equivalent to m times x2 plus n times x1 divided by m plus n, and then m times y2 plus n times y1 divided by m plus n. All right, so minus 4, 6, that can also be represented as, well, m and n are unknown, so we'll just leave it like that. M times what's x2? X2 is m times 3 plus n times minus 6 by m plus n, and m times y2 is m times minus 8 plus n times 10 divided by m plus n. Okay, so we could use either one. I'll use this part to form a relation between the variable m and n. So minus 4 is equal to what? 3m. Well, they're equal because this is called an ordered pair. So this part will be equal to this, and this is equal to this part, okay? So 3m minus 6n divided by m plus n is equal to minus 4. Now if we just simplify this, well, we're done. We'll get a relation between m and n, and we just need to find m divided by n. So let's simplify this further. 3m minus 6n is equal to 4 times m plus n. 3m minus 6n is equal to 4m minus 4n, or 3m plus 4m is equal to minus 4n plus 6n. 7m is equal to 2n. m divided by n is equal to 2 divided by 7. That is our answer. So m is to n is equal to 2 is to 7. So that point divides the line segment in this ratio. Okay, cool. So now we move on to question number 28. Question number 28. Okay, the expression might look scary, but remember that all of those are actually standard angles. So you just need to plug in the values and then you're done. So sine 30 degrees plus tan 45 degrees minus cosec 60 degree divided by the whole thing, sec 30 degree plus cos 60 degree plus cot 45 degree, right? So this whole thing is equal to what is sine 30? Sine 30 is 1 by 2, tan 45 is 1, cosec 60 is 2 by root 3, just the reciprocal of sine 60. So that's how, if you remember the values for 3, the other 3 are straightforward to figure out. What is sec 30? Well, sec 30 is 2 by root 3. That is the reciprocal of cos 30 plus cos 60 is 1 by 2 and cot 45 is 1. So on simplifying this, we get root 3 plus 2 root 3 minus 4 divided by 2 root 3. So that's the numerator. The denominator becomes 4 plus root 3 plus 2 root 3 by 2 root 3. So yeah, I chose to combine all the 3 at once, but you could do 1 by 2 plus 1. That will give you 1.5 and then minus this term, but okay. So this is where a lot of people make mistakes, so you just be careful. This can be rewritten as minus 4 plus 3 root 3, this gets cancelled, divided by 4 plus 3 root 3. Now we can rationalize, so minus 4 plus 3 root 3 multiplied by 4 minus 3 root 3 times 4 plus 3 root 3 multiplied by 4 minus 3 root 3. Okay, so this is so if we multiply this, we get a squared minus b squared. So In the denominator we get 4 squared minus 3 root 3 squared, and in the numerator, so this is essentially so if we multiply minus 1, for example, here, so this becomes plus, this becomes minus, and outside we have minus 1. So that's nothing but minus 4 plus 3 root 3 whole squared multiplied by minus 1. Okay. You can do the simplification. Just be patient. Plus 4 squared minus 2 times. So this is just like a minus b whole squared. Okay. 2 times 4 times 3 root 3, and I have the minus 1 from the adjustment, divided by 16 minus 27. Okay. So I get minus 11 in the denominator. I also have minus 1, so this can be cancelled, and the numerator is, on simplification, you'll get 27 plus 16 minus 24 root 3. Okay, so that is nothing but 43 minus 24 root 3 divided by 11. That's our answer. So it's fairly straightforward. The only parts where one can make mistake is in simplifying these parts. Yeah, I think that's why the question also carries a fair bit of mark, because students are prone to make mistakes. Yeah, apart from that, I think it's fairly straightforward. It's just addition of, irrational numbers, fractions, and so on. So moving on to question number 29. So it says, if a line is drawn, okay, so we used the result, this same result in solving question number 9. So what does this say? It says, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, okay, prove that the other two sides are divided in the same ratio. Okay. So let's first draw a triangle. Maybe I should draw a bigger one actually. Okay. So we name the triangle, let's say A, B, C. There is some D and E. So to prove, in simpler terms, I need to prove AD divided by DB is equal to AE divided by EC. Okay, that's what I need to prove. How might one approach this? Well, let's connect this. I'm just connecting them. So you could probably see the triangles, right? This triangle B, D, E, and triangle B, C, E. I'll use them later. What else? Okay. So yeah, that's what I need to prove. Now let's say, so we need to construct something. So construction. I'm going to construct a line segment. Okay. This is, let's call this X. Similarly, let's call this Y. So I'm constructing two altitudes. Construction, draw EX perpendicular to AD, okay, and DY perpendicular to AE. So that's the construction that I'm doing. I'll tell you why. That's so that we can find the area of triangle ADE. Okay, so there's another triangle ADE. Let's start. How might we get, let's say, the left hand side of this equation? AD by DB I need, right? So AD by DB, I need to connect those two line segments somehow. Well, let's say area of triangle BDE divided by area of triangle BDE. Okay, so let's not go ahead with the larger triangle. Maybe I'll keep the smaller triangle in the numerator. So area of triangle ADE, right? If we divide this by the area of triangle BDE, what do we get? What is area of triangle ADE? First of all, ADE. So ADE, this triangle. What's the area? Well, area of a triangle is half into base into height, right? What's the base? Base in this case is AD. Okay, so AD is the base. What's the height? Well, height we have constructed EX, so that's our height. What's the area of triangle BDE now? BDE also has the same height, so BDE, this is the height, right? The height is common for both the triangles, so half into, what is the base? Base is BD into EX. Okay, similarly we could also write area of triangle ADE divided by area of triangle CDE. Okay, so again this triangle divided by this triangle. So area of triangle ADE is half times AD, base into height. We have constructed another height also, so that's the AE. Sorry, it's not AD. The base is AE in this case times dy, right? Dy is the height that we constructed, divided by what is the area of CDE. So that's half into base is CE times dy. So as you can see, AD by DB we get from this equation, and AE by CE we get from this equation. If we can equate them somehow, then we're done. How can we equate them? Well, if you look at area of BDE and CDE, they are between two parallel lines, parallel line BC and parallel line DE, right? So those two areas are actually equal. So this area is equal to this area. Sorry, not that. This area is equal to this area. Why? Well, because area of triangle BDE is equal to area of triangle CDE. Why? Because triangles on the same base and between two parallel lines have equal area. Okay, so the condition is they're on the same base. The base is DE. If you look at, this is the base of that triangle, both of them, and they're between two parallel lines, so their areas are equal, right? So now area of triangle BDE is equal to CDE. Okay, that we have established. So if this denominator and this denominator are equal, the numerators are the same, that means this equation 1 and this equation 2, they must be equal. So that gives us AD divided by BD is equal to AE by CE, which is what we wanted to prove all along. So hence proved. Okay, so that's question number 29, I believe. Yeah, that's question number 29. So yeah, fairly involved in how we manipulate the terms and all of that, but I hope it's clear. You can rewind and watch it again. Let's continue with question number 30. So what does question number 30 say? Question number 30 says, using Euclid's division lemma, prove that the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. Well, first of all, what's Euclid's division lemma? So it's nothing but Euclid's division lemma says if there is a number x, it can be expressed as a form in this form, so y times q plus r, whereas this condition holds. So this essentially just means any number x can be expressed as some quotient times this y plus some remainder. Okay, so that's what the lemma says. Now we need to prove that cube of this number x cube, that looks something like 9 times some m or 9m plus 1 or 9m plus 8, something like that. Okay, so how might we approach such a problem? Well, let's try taking some numbers. So what is 2 cube? 2 cube is equal to 8, right? How can we express that? So that can be expressed as something like 2 times, for example, 3 plus 2, right? Or equivalently, you can also express it as 3 times some 2 plus some remainder 2. Okay, what about 3 cube? 3 cube is 27. That can be expressed as 3 times 9 plus 0, right? Or how about 4 cube, which is 64? So that can be expressed as 3 times 21, which gives us 63 plus 1. So if you notice, I'm essentially, so there is some number 3, right, times q, this is q, q, some q, and we have some remainders, these are the r's, right? So if we assume let the number x be of the form 3 times some quotient plus remainder, right? If the number looks like this, then we can try to express x cube as something. Well, by this property, so in this case r would just be 0 less than or equal to r less than 3, right? Since we've assumed y to be some number 3. So this gives us either r could be 0 or r could be 1 or r could be 2, right? So we got 3 cases. Let's solve them one by one. Case 1 is when r is equal to 0. So what does the number x look like in that case? That would just be 3 times q plus 0 is equal to 3q. Now cubing both sides, x cubed is equal to 3q whole cubed. So x cubed is equal to 3 cubed times q cubed, which is equal to 9 times 3q cubed. I'm just rearranging and factorizing this. So if we assume m is equal to 3 cubed, then x cubed looks like 9 times m, right? So that's our first case. That's what we wanted to show. How about the second case, case 2, where r is equal to 1? So in this case, x looks like 3 times q plus 1. Again, cubing both sides, x cubed is equal to 3q plus 1 cube. This is nothing but a plus b whole cubed, which is a cubed plus b cubed plus 3 times a times b multiplied by a plus b, right? Simplifying that further, we get x cubed is equal to 3 cubed q cubed plus 1 plus 9q multiplied by 3q plus 1, or we could write x cubed is equal to 27 q cubed plus 1 plus 27 q squared plus 9q. Okay, so if we rearrange this, x cubed is equal to 9q 3q squared plus 3q plus 1 plus 1, right? I'm just rearranging this term. So let m equal to 3q squared plus 3q plus 1, then we just get x cubed is equal to 9q multiplied by some m plus 1. Okay. Well, actually I can further rearrange this. So instead of doing this, what if I keep q multiplied? So x cubed is equal to 9 times 3q squared plus 3q 9 times 3q cubed, sorry, plus 3q squared plus, well, q plus 1. This can be equivalently expressed as this. So let's just assume m is equal to this plus q, right? So that gets rid of this term, which conveniently gives us x cubed is equal to 9m plus 1. This is our second case, what we wanted, right? So we wanted to show that's equal to something like this, which we have shown. So the second case is also satisfied. Now the third case, where r is equal to 2. So we get x is equal to 3 times q plus 2, and x cubed is equal to, well, we just cube both sides, right? So this gives us 3 cube plus 2 cube plus 3 times 3q times 2 times 3q plus 2. Okay, so that gives us 27q cubed plus 8 plus 54q squared plus 36q. So now on simplifying, what do we get? Well, let's just take 9 out. So this gives us 3q cubed plus 6q squared plus 4q plus 8. So we're just rearranging the whole thing into this, okay? Which, if we assume m is equal to 3q cubed plus 6q squared plus 4q, is nothing but x cubed is equal to 9m plus 8, which is what we wanted to show. That's our third case. So yeah, there you have it. Question number 30 is solved. Let's move on to question number 31 now. Okay, so question number 31 says solve, okay, 1 by x plus 4 minus 1 by x minus 7, which is equal to 11 by 30. Obviously x cannot be equal to minus 4 or 7, because in that case you'll get 1 divided by 0, which is undefined. Okay, so we simplify the left hand side. So 1 divided by, so 1 multiplied by x minus 7 minus 1 multiplied by x plus 4. Then we have the denominator, which is x plus 4 times x minus 7. That's equal to 11 by 30. Let's simplify a little bit. So we get x minus 7 minus x minus 4 divided by x plus 4 times x minus 7, which is equal to 11 by 30. Okay, next we simplified some more. So x minus x is 0, minus 7 minus 4 is minus 11 divided by the denominator. That is equal to 11 by 30. So this 11 and this 11 cancels. So we're left with x plus 4. I'm just cross multiplying, times x minus 7 is equal to minus 30, right? Now we open this up. So x squared plus 4x minus 7 x minus 28 is equal to minus 30. So we take everything on the left hand side of the equation. So this is x squared minus 3x minus 28 plus 30 is equal to 0, or x squared minus 3x minus, actually plus 2 is equal to 0. This can be rewritten as x squared minus x minus 2x plus 2 is equal to 0. If we take x common, this is x minus 1 minus 2 common, my x minus 1 is equal to 0. So x minus 1 multiplied by x minus 2 is equal to 0. So either x minus 1 is equal to 0 or x minus 2 is equal to 0. So we get x equal to 1, x equal to 2. So those are the solutions. X could either be 1 or 2. You could plug them back into this equation and confirm that that's indeed correct. So this is our answer. Okay, we move on to question number 32 now. So what does question number 32 say? Question number 32 says, prove that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, so let's make a diagram. So we have our circle. Let's say that's the center of the circle. Some tangent is drawn. So let's draw a tangent. Okay, that's our tangent. Let's name this O. So the claim is, this is my radius. The claim is that, the claim is that this is perpendicular. Okay, so to prove, let's name this point as A. Let's take some point B on the tangent. This is some arbitrary point. Okay, so B could be here, here, or here even, or maybe here. Okay, it doesn't really matter. So B is some arbitrary point on the tangent. So now let's join this. Okay, so we call this intersection point as C. So what I want to prove, that OA is perpendicular to AB. Okay, that's all I want to prove. So how might we go about this? First thing, if you notice, the line segment OA is equal to OC. Why? Because those are the radii of the same circle, so obviously they must be equal. Okay, next, what is OB? If you look at it, OB is nothing but OC plus CB. So we write OC plus CB. Okay, which means since CB is a line segment, so obviously the length of a line cannot be 0, right? So the CB is some positive number, okay, greater than 0, because it's a distance. That gives us OB greater than OC, right? Why? Because since CB is a positive thing, so OB is OC plus something more. So we can confidently say that OB is greater than OC, right? Now, since OC and OA are equal, so we can also claim that OB is greater than OA. Okay, so I'm just substituting that here. So we claim this also. Okay. So if you look at all the lines, so let's say there's some line which joins this or this or whatever, or any point on the tangent AB, then OA is the shortest line segment. Okay, why? Because like I said, for any random point B on the tangent, OB is greater than OA. So OA is clearly the shortest line. But we also know, the shortest distance of a point from a line is the perpendicular distance from that line. Okay, So since OA is the shortest distance from point O to the line segment AB, OA must be perpendicular to AB. Okay, so which is what we wanted to show. So OA must clearly be perpendicular to AB, hence proved that the tangent at any point is perpendicular to the radius. Okay, so through the point of contact. So this is what we wanted to show, and that's what we have shown. So we're done with question number 32. So this is the first option. There was also one more, so the OR option. Since I'm solving all of them, I'll just solve this one also. So what we want is two tangents TP and TQ are drawn to a circle with center O. First of all, let's make a circle with center O. Okay, so that's my circle. There's some center O. TP and TQ are the tangents. Okay, so there's some point T outside. So I want to draw two tangents. So let's connect these points. So that's P, that's Q, and this is my T. Okay. Using the result above, so this has to be perpendicular. This also has to be perpendicular. Okay. So to prove angle PTQ is equal to 2 times angle OPQ. So what is PTQ? PTQ is this angle right there. That's twice OPQ. Okay, so what is OPQ? Let's connect this. So that's some angle. Let's call it X. So that is twice OPQ. Okay. Fair. So let's consider in triangle OPQ. Okay, so this small triangle, we'll look at it. In triangle OPQ, OP is equal to OQ. Why? Because that's the radius of the same circle, so obviously they must be equal. That means triangle OPQ is an isosceles triangle, which means this angle. So that means angle OPQ is equal to angle OQP, because that's an isosceles triangle. So these two angles are equal. So if we assume that angle is X, this also has to be X. Now in quadrilateral OPTQ, so if you look at the quadrilateral, what we can write is angle PTQ. So this angle plus 90 degrees. So this angle plus angle POQ. So this angle plus 90 degrees. This angle, that is equal to 360 degrees. That's just the angle sum of a quadrilateral. So we get angle PTQ plus angle POQ is equal to 360 degrees minus 180 degrees. So that's just 180 degrees. Again, in triangle POQ, if you look at angle So now we'll use the angle sum property of a triangle. So angle POQ plus x must be 180 degree. So that's the angle sum of a triangle. So in this triangle, this angle plus this angle plus this must be 180 degree, obviously. So we have angle POQ plus 2x is equal to 180 degree. Right? So now I just substitute. So if this is equation 1, if this is equation 2, since they are both equal to 180 degree, I can write angle PTQ plus angle POQ is equal to angle POQ plus 2x. This is from equations 1 and 2. So this go away. So therefore angle PTQ is equal to 2 times x, where x is nothing but angle OPQ. So x is just that. So x is nothing but angle OPQ. Therefore, angle PTQ is equal to 2 times angle OPQ. Hence, proved. So that's all we needed to do, right? So then we move on to question number 33. Moving on to question number 33. So from a point P on the ground, the angular elevation of the top of a 10-meter tall building is 30 degrees. Okay. So there is some building, let's say, and then this is the ground. There's some point P here. So the angular elevation is 30 degrees. Okay. And this is 10 meters. Cool. A flag is hoisted at the top of the building, and the angular elevation of the top of the flagstaff from the point P is 45. Okay. So some flag is hoisted. Let's make the flag rectangular, because why not? Okay. So the angular elevation from here, that is 45 degrees. So the angle is measured relative to some horizon. So in this case, it's the ground, right? So we get the angular elevation in both cases. Find the length of the flagstaff. Okay, so let's just call this h. I need to find this distance, and the distance of the building from point P. So let's call this D. So I need to find this distance. Okay. Well, how might we approach this problem? So let's try writing some trigonometric equations. So what, let's say tan 30 degrees is equal to what? So that's this angle. So tan is opposite side divided by the adjacent. So 10 divided by D. So D is equal to 10 divided by tan 30 degrees, which is 10 divided by 1 by root 3. So this is equal to 10 root 3 meters, which is approximately equal to 17.32 meters. Since the question also says you may take root 3 equal to 1.732. So this distance we found out, that's approximately 17.32 meters. Next we need to find h. How might we find that? Well, let's write one more equation. So tan 45 degrees is equal to, so now this angle, so that's opposite side, which is tan plus h divided by d. Okay, so tan 45 is 1, therefore d times tan 45 is equal to tan plus h, or h is d minus 10. Okay, which is 17.32 minus 10, which is equal to 7.32 meters. So those were the two things that we needed to find, and we found them. So we move on to the next question, which is question number 34. What does question number 34 say? So question 34 says, a medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. Okay, let's try drawing it. So there's some cylindrical structure, right? And then there's two hemispheres stuck to the end of it. Okay, cool. The length of the entire capsule is 14 millimeters. So the length from here till this end, that is 14 millimeters. Makes sense, because if they said the length of the capsule is 14 meters or something, it would be unrealistic, right? And the diameter of the capsule is 5 millimeters. So the diameter, this distance, that is 5 millimeters. So we find out the radius, which is this distance. So radius is nothing but 5 millimeters divided by 2, which is 2.5 millimeters, right? Now I need to find the surface area of the capsule. Okay, so surface area means this and this area, sort of, and also this, obviously. So how might we find the surface area? So let's write down the equation. Surface area is equal to the lateral surface area of the cylinder, so that is this part, right, plus curved surface area of the two hemispheres. Okay, so that's this area plus this area. Well, what is the lateral surface area of the cylinder? That is 2 times pi times r h plus, for the two hemispheres, that is 4 pi r squared. So curved surface area of two hemispheres is also equal to the surface area of a full sphere, right, which is 4 pi r squared. Well, I know r I found out as 2.5. I need to find h. H is nothing but the height of the cylinder. So from here to here, how can we find h? Well, h is equal to the total length of the capsule, which is 14, minus this length, right, which is nothing but the radius of the hemispherical part. So minus 2 times the radius, which is 2.5. Why 2 times? Because I need to subtract this distance and also this. So that gives us 14 minus 5, which is 9 millimeters. Okay, so now we can find the surface area, which is equal to 2 times pi times r is 2.5 multiplied by what is height? 9 plus 4 times pi times 2.5 squared. So this is just equal to 70 pi millimeters squared. Okay, if you want to simplify it, you can take pi to be 22 by 7, so that gives us 220 millimeters squared. Okay, next we also need to find the volume. Okay, so volume is equal to volume of the cylinder plus volume of two hemispheres, which is nothing but volume of a full sphere. So what is the formula for volume of a cylinder? That's pi r squared h, and volume of a hemisphere is, no, volume of a full sphere is 4 by 3 pi r cubed. So that's equal to pi times 2.5 squared times 9 plus 4 by 3 times pi times 2.5 cube, and the unit would be millimeter cubed. Okay, so that is equal to 925 divided by 12 pi millimeter cubed. Okay, so if you want to simplify, you can just plug in the value for pi and sort of simplify, but I'll leave it here. Okay, so we found the surface area as well as the volume. So we're done with question number 34. Now moving on to question number 35. So it's a probability problem. One card is drawn from a well shuffled deck of 52 cards. Okay, so find the probability of getting, the first question is a king of red color. So in a deck of cards there are 4 kings, 2 red and 2 black. So if you draw a card from a well shuffled deck, the probability of getting a red colored king is, so since there are 2 red ones, 2 out of how many cards are there? There are 52 cards. So this is nothing but 1 by 26. How about the second one? The jack of hearts. Okay, the jack of hearts. How many jack of hearts are there? So there's actually just one jack of heart, and the total number of cards is 52. So that's your answer, 1 by 52, right? So there are 4 jacks belonging to each belonging to each of the 4. So a jack of hearts is just like 1 by 52. The third is an ace. So how many aces are there? There are 4 aces in a deck of cards. So 4 out of 52, which is 1 by 13. The fourth one is a face card. There are actually 12 face cards. So 3 face cards for each hand. So 12 out of 52, that is 3 by 13. Okay, so yeah, we're done with question number 35 also. So question number 36. The distribution below gives the weights of 30 students. So well, n is equal to 30 of a class. Find the median weights of the students. Okay, so we're given a table, we need to find the median. So finding median is fairly straightforward, right? When you have discrete collection of data points, you can just arrange them in some order and find the median. Sadly, we can't do that here, and obviously that's why they've given 4 marks for this. So in the group distribution table case, median is determined by a formula which is L plus n by 2 minus CF divided by F times H. We'll find each of these variables out one by one, okay? So just stick with me here. So let's make a table. So this is the class. So that's the class. And then we have frequency. And then we have cumulative frequency, okay? So the class 40 to 45. So we have the class 40 to 45, then 45 to 50, 50 to 55, then 55 to 60, then we have 60 to 65, after that 65 to 70, and 70 to 75, okay? The frequencies are 2, 3, 8, 6, 6, 3, and 2. So what's the cumulative frequency? For the first one, it's just 2. Then the next one is 5. So we add this and this. Similarly, we'll add this and this for the next one. So 8 plus 5 is 13. Then 19. Then 25. Then 28. And then finally 30. Okay. So we need to find out what is n by 2. That's just 15. 30 by 2 is 15. So where does 15 lie in the cumulative frequency table? So 15 lies here, right? It lies here. So 15 lies there, which means that's our median class. Okay. So what is this? L stands for L is the lower limit of the median class. Okay. So looking at the table, what's the lower limit of the median class? It's 55. Okay. So we got this variable, we have n. I need to find out CF. What is CF? CF is cumulative frequency of class preceding the median class. Preceding median class. So this is the median class. The class preceding it is this one. So the CF, cumulative frequency of the class preceding the median class, is 13. Okay. So we've determined that also. Now what is F? F is the frequency of the median class. So in that case, F is just 6. So F, frequency of median class, that is nothing but 6 in our case. And we're left with one variable, which is H. H is the class size or height. So it just means the width of this class, which we can find out since all the classes are balanced. So that's nothing but 60 minus 55, which is just 5. Okay, so now median is equal to L plus n by 2 minus CF divided by F times H. I just plug in all the numbers. So this is 55 plus n by 2 is 15 minus what is CF, that's 13, divided by F is 6 times what is H, H is 5. So this is just equal to 55 plus 2 by 6 times 5, which gives us 170 by 3, which is approximately 56.67 kg. So that's the median weight of the students. Okay, so we're done with section 5 and question number 3. We move on to section 6 now. Okay, so we're down to the last few questions. So we solve question 37. What does question 37 say? In an equilateral triangle ABC. Okay, so let's draw the triangle first. Okay, that's supposed to be an equilateral triangle. We call it A, B, C. D is a point on side BC. Okay, so such that BD is equal to 1/3 BC. Okay, so there's some point D here. Let's join this two. So this is 1/3 BC, that distance. For simplicity, let's assume that side of the triangle ABC is equal to small a. So this is small a, this is small a. Similarly, BC is also small a. So this part becomes 1/3 small a. Therefore, this part will be 2/3 small a. How did I get that? Well, this is just equal to a minus 1 by 3 a, right? Okay. So next, prove that. Okay, so we need to prove 9AD squared is equal to 7AB squared. Okay, so how might we approach that? Well, let's find the let's draw one more point. So this is the midpoint of BC. Let's name it E or something. So that's the height of the triangle ABC. That's the altitude. So what's the length? So this part is a by 2 because that's the midpoint. So what's the height of the triangle? Let's say h is equal to, well, we can use the Pythagorean theorem. So that's just a squared minus a by 2 whole squared and square root of that, right? So this is a squared minus a squared by 4 square root, which is 4a squared minus a squared by 4 and root of that, which is equal to 3a squared by 4 and square root. So this gives us root 3a divided by 2. Okay, so that's the height. Height is root 3a by 2. Okay, it'll come in handy later on. So next, let's draw two more lines. So we construct a line from here that is perpendicular to the side AB. Let's call this P. Similarly, we draw another altitude from here. to the side AC. Let's call this Q. Okay, so now take the triangle CDQ. Okay, so CDQ, so this triangle right here. Okay, this triangle. So let's draw it out separately. So let's say this is the triangle CDQ. It's perpendicular. DQ is perpendicular to CQ, so we have the angle here. What is this angle? That's here, right over here, which is nothing but 60 degrees. Why is it 60 degrees? Because this is an equilateral triangle, so all the angles of the equilateral triangle, they're equal to 60 degrees, or total 180. Okay, and so we have that, and we also know the length of the side CD, right? This, we know this side from here, so that's equal to 2 by 3a. Now, using trigonometry, what we can do is we can find this side, right? So sine 60 degrees is equal to dq divided by 2 by 3a, right? What is sine 60? Sine 60 is nothing but root 3 divided by 2, which is equal to dq divided by 2a, and the 3 goes to the numerator, so 2 and 2 gets cancelled. So therefore dq is equal to root 3a divided by 3. Okay, next we also have, what do we have? Cos 60. So cos 60 degrees is equal to CQ. So this side divided by 2 by 3a. What is cos 60? Cos 60 is 1 by 2, right? So 1 by 2 is equal to CQ times a, sorry, CQ times 3 divided by 2a, so this gets cancelled, therefore CQ is 1 by 3a. Okay, so we have DQ and CQ now. Next, what we can do is, again, similar to the triangle CDQ, we take triangle AD, so we take the triangle AD and Q. So we take the triangle ADQ. Okay, so let's just draw the triangle. Okay, so A, Q, D, and this is perpendicular. What do we have here? So if we take this triangle, what is AQ? AQ from this figure, right? So what is AQ? This side we know, CQ is 1 by 3a, therefore AQ must be 2 by 3a, since the length of AC is a, so AQ is 2 by 3a, and we know DQ we found out here, so DQ is root 3 a by 3. Okay, So using Pythagoras theorem, we can write AD squared is equal to AQ squared plus DQ squared, which is nothing but AD squared is equal to what is AQ squared, 2 by 3A squared, plus what is DQ? DQ is root 3A by 3 whole square. So that gives us AD squared is equal to 4A squared by 9 plus 3A squared by 9, which is nothing but 7A squared by 9. That's AD squared. Therefore, 9AD squared is equal to 7A squared. Now what is A? A is the side of the triangle, so that's equal to AB, that's equal to BC, that's equal to AC. So therefore we can write 9AD squared is equal to 7 times AB squared, which is what we needed to prove. Hence, prove. Okay. So that's the solution for question 37, sorry. So we now move on to the last question of the question paper, question 38. It has 2 parts, so we'll solve them one by one. The first part says, find the 24th term and the sum of the first 48 terms of the list of numbers whose nth term an is given by 3 plus 2n. Okay, so let's first find the 24th term, which is a24. That's equal to 3 plus 2 times 24, which is nothing but 3 plus 48, that's equal to 51. That's the first part of our solution. Next, we need to find the sum of the first 48 terms. So S48 is equal to what? Okay, so Sn is given by n by 2 times a1 plus an, right? So in this case, S48 will just be 48 by 2 times a1 plus a48. Okay, so what is 48 by 2 times, what is a1? We can just substitute here. So a1 is equal to 3 plus 2 times 1, which is equal to 5. So we have 5 plus what is a48? That's nothing but 3 plus 2 times 48, right? That gives us 3 plus 96. Okay, so that gives us what? That gives us 99. Okay, so this is 99. That's nothing but 24 times 5 plus 99 is 104. So that's equal to 2496. Okay, so that's our answer for the first part. Next part says, that's one answer and this is one answer. Next part says, the difference of a number and its reciprocal is, so let the number be some a. So the question claims the difference of a number and its reciprocal is 58. This. Okay, so this is nothing but a simple quadratic equation. So let's simplify the left hand side, which gives us a squared minus 1 by a is equal to 3480 divided by 59. How did I get that? Well, this is just equal to 58 times 59 plus 58 So I'm just divided by 59. So I'm just converting the mixed fraction into a proper one. Okay. So a squared minus 1 by a is equal to 3480 by 59, or 59 a squared minus 59 is equal to 3480a, right? So now simplifying that further, we get 59 a squared minus 3480a minus 59 is equal to 0. So we can use the formula for determining the values of a. So that for this quadratic equation, that is of this from minus b plus minus root a squared minus 4ac divided by 2a. Okay, so the two solutions are minus, what is b? B in this case is minus 3480 plus minus root. What is a squared? Well, a squared is just 59 squared minus what is 4ac, 4 times what is a, 59, times what is c, minus 59. Okay, so that's divided by 2 times 59. So this is nothing but 3480 plus minus root 12124. So if you simplify this, you'll get this. So calculators are allowed in the exam, so you can just use your calculator to figure this out. 3480 plus minus the root comes out as 3482 divided by 118. So the two solutions are, one is 6962 by 118, which is actually equal to 59, since the other solution, well, the other solution is the reciprocal of this. So we get the other solution as minus 1 by 59. Okay, you can just confirm that their difference is indeed what the question paper claims. Okay. So yeah, that's pretty much it. 59 and minus 1 by 59. So these are the two possible solutions. We can call them A1 or A2, whatever you want. Okay, so yeah, indeed reciprocal. So 59 minus 1 by 59 is equal to whatever was claimed. So this number, similarly, minus 1 by 59 minus reciprocal of that, so that's minus 59. So that's again 59 minus 1 by 59, which also gives us whatever number this is. Okay, so that's the solution to the question paper. We're done essentially.